Function notation. Really, this is just substitution in disguise. So we have a function up here at the top. It's h, and then in parentheses s equals 6s plus 10. Function notation just means we're using the name of the function is h. Okay, that h is not a variable. That's the name. It's the h function. We can call this Henry. It's the Henry function. Okay, and then the s in parentheses is the variable that's being used. So if we want to find h of 4, what that's saying is use the h function and plug in 4 and tell me what you get. So I know that sounds kind of strange, but if sometimes you have problems that have like an h function, a g function, and a k function. So you got to know which one to use. So that's why we are saying h of 4. Now in this case, they only give us one function, so we don't have to make that decision. But all this means is we're going to take that 4 and plug it into the function every place we see an s. It's only in... So when I go to plug it in, h of 4, that means h function, my input is 4, so I just substitute the 4 in for the s and then do my calculations. So h of 4 is going to be 24 plus 10. So h of 4 equals 34. So what that means is when I use function h and my input is 4, my output is 34, is how that translates. So that's the answer to the first part. Now, I made sure I showed all my steps. You don't have to show all your steps if you don't want to. If I plug in negative 10, so if I just take s times negative 10 plus 10, what am I going to get? It looks like negative 50. And then if I plug in 6.9, so 6 times 6.9 plus 10. 6 times 6 plus 9, or 6.9. I know I wrote it down somewhere, I thought. Oh, there it is. Oh, I didn't write down what that was individually. I just got 51.4 for the whole thing. So it must have been 41.4. And then add the 10. So there's my answers there. So h of, when I plug in 4, I get 34. When I plug in negative 10, I get negative 50. And when I plug in 6.9, I get 51.4. So it's just a substitution. All right, this one, number 5. Find an equation of the line having the given slope and containing the given point. So remember how we did that one that was perpendicular? That's actually a harder one than this one. Because I'm given a point and I'm given a slope, I'm going to start with that point-slope form. Now, this is on your formula sheet. So if you look at that and you're like, I'm never going to remember that. It's on your formula sheet. So you just have to make sure that you know how to use it. So it's y minus the y coordinate. So y minus 1. They give me my slope of 9. Remember on that other problem we actually had to find the slope that we were going to use. So this one they gave it to us. And then x minus your x coordinate, so it would be x minus 2. Now because they want the equation in y equals form or slope-intercept form, I've got to get y all by itself. So I have to distribute my 9, which is going to give me 9x minus 18. And then add 1, add 1. So this one's definitely easier than the other one because the other one had fractions in it too. So this one, y equals 9x minus 17. So just because it says it wants the answer in slope-intercept form, you need to start with what you're given. Since you're given a point and a slope, use point-slope form. It's going to be, even though that's not the form that they want it in, you can always manipulate it later. You can use slope-intercept form, but you've got kind of 2 steps that you have to do, and I just find it's easier to do it this way. Okay? All right. Number 6.